Okay, question 2 on page 29, our second example of practice sex-linked trait question. This still pertains to some of the information in question 1, where it talks about it being hemophilia being sex-linked, and it's sex-linked recessive. So let's just go back to a quick little legend, always our step 1. If I have an X, and I'm going to put just an X with normal, nothing on it, that's just going to be a normal male or female. Okay, and if I have X with a little h, X with a little h, that's going to be a hemo, and I'll just abbreviate that, female. And of course, if I have an X with a little h and a Y, that's going to be a hemo, male. Okay, and carriers, again, do not exhibit the actual hemophiliac symptoms, because the normal X will mask the expression of the one that's potentially carrying the hemophiliac allele on it. Okay, so let's take a look at question number 2. It says indicate the genotype and the phenotypic ratio of offspring from mating. A normal male, underline the parent, tell me his genotype. So if he's a normal male, he has to have just an X with a Y on it. And he's mating crossed with a carrier female. So she is actually going to be normal as well, because just like we said, the normal X is going to match the expression of the allele with the hemophilia on it. But she is a carrier, so that's what a carrier looks like. So that's our cross. We know what the answer is supposed to be. Let's just work it out really quick here. Same thing, it's still a type of monohybrid question, where we're just looking at one particular trait or disorder, in this case hemophilia. So we'll put the female across. We're going to isolate those into gametes, right? Take genotypes and isolate them to gametes. So half of her eggs are going to have the X with just normal, and the other half of her eggs are going to be carrying the hemophiliac allele. And then we're going to isolate the male over here as well. So that's going to be in his sperm. So this is actually in the sperm, as we've been saying. So half of his sperm is going to be contributing the XX chromosome, and if he contributes that sperm, going to be a female, the offspring. The other half are going to be carrying the Y sex chromosome, and that will contribute to a male if that's the actual gamete that fertilizes the egg. So now bring them together, X and X, that's just going to be a normal female. X with an X with a little H on it is going to be a normal, still going to be a normal female, but she will be a carrier, but she will still exhibit normal characteristics, not any of the symptoms for hemophilia. X and the Y, that's going to be a normal male, and the X with the Y is going to be a hemo male. So what we're going to get here for our ratio, if we take a look at it again, you have to separate females and males. You're going to have 2 normal females. Oh, let's just put the symbol. 1 normal male and 1 hemo male. And that gives us the answer of a 2 to 1 to 1 ratio. Okay, any issues, just give me an email. Thanks, guys.